Hey everybody, in this video I'm going to finish the implementation of jumping into our distance matching animation blueprint setup here, and there's not really much more to say. This is pretty much a direct continuation of the last video. The only thing I do want to note is that this isn't a completely distance matching approach. This could be done very easily in a way that's similar to the start and stop animations, but I just don't have the right kind of jump animations with distance curves or anything like that to really do it. So I'm using, I'll be using animations from the advanced locomotion system. They'll work well, and I can still use the location distance code to determine when I transition from the jumping animation to the flailing animation and when I land and those kinds of things. So without further ado, let's just jump right in. I'm starting this video inside of the advanced locomotion system project because we need to move in some jumping animations. I want this flail animation, and I want this jump loop animation. I'm going to right click, I'm going to go to asset actions, I'm going to go to export. I'm going to export them into my distance matching project. You might see that they're already there. That's because this is the second time I've recorded this, and you'll get this message here: 2 changes to source content. You can import them, and it'll ask you to select a skeleton. Select the Unreal Engine mannequin skeleton. Now, I recorded a good 20 minutes, maybe even 30 minutes of video, of audio, without realizing that I didn't record the video just a moment ago, and I don't feel like going back and redoing absolutely everything I just did. So I'm going to walk you guys through what I've changed in the last somewhere between 20 and 30 minutes here. Inside of the character blueprint, I've added on this code here to finish up the calculations. I have this get actor location, break vector, and then I'm breaking the vectors of the apex location out and the landing location out. I'm getting the difference between the apex location and the actor location, and I'm getting the difference between the landing location and the actor location. And the differences are all the differences in the height in Z. I don't care about X or Y. I'm getting the absolute value of the differences. That'll just give me the distance between the character and either of these points. And I'm setting 2 new variables, apex distance and landing distance, on a tick-by-tick basis if is falling, which I'm getting from character movement, is true. And this is just plugged into my sequence node up here from event tick. Now, I'm setting a new boolean jumping to true when we press input action jump, and I'm setting it to false once we have this once we set this landing distance right after it. That's everything that I've changed here. I go into predict jump arc. Everything's the same. The things that have been changed aren't plugged into anything. So, just to show that. Now if I go into the animation blueprint, you'll notice the event graph is gone. And well, not really gone, just condensed into collapsed graphs. So I have this set essential values graph where I'm setting all the variables. You guys can go in and organize your animation graphs. You probably have been more than I have, but I'm just pulling is jumping, or jumping, I named it is jumping, apex distance to apex distance, landing distance to landing distance, just by dragging out and clicking promote to variable on all three of these. And all this other stuff like the set direction is this code here, where we're getting setting our direction last tick from direction, and we're calculating our direction. And if our velocity is 0, we're setting the direction with the direction from the last tick, so that we keep the orientation warping when we stop. After that, I have this set orientation warping values collapsed graph, which is just setting all of our orientation warping values. It's that section. I have this get curve times, which is where we set our two curve time variables, our start time and stop time. Then I have the root yaw calculation stuff all inside of here. So feel free to follow along or not. The only change we're making in this video is in this set essential values right here, adding these 3 new variables. Now, if I go into grounded locomotion, you'll see that the ground IK, the ground alignment node from power IK, is gone. I've cut it and I've pasted it right after our blend poses by int, using cardinal direction to blend our orientation warping, right after all of that, before output animation pose inside of grounded locomotion. Just cut it from our graph further up and pasted it in here. And now, if you go into grounded locomotion, which is where we have, you can see it here with our rotate root bone and leg IK, I have this jumping state, which is plugged into locomotion with 2 transitions. Transition from locomotion to jumping is default settings and is using isJumping as the can enter transition boolean. Jumping to locomotion is just saying if the landing distance is nearly equal to what it should be 10, not 5, I think. That'll give us enough leeway for landing on slopes and stairs and that kind of thing. And then inside of jumping, there's a state called jumping, the state machine called jumping, I'm sorry. Inside of it, there are 2 states. A start state, which plays our ALS in jump loop. A transition into loop, which is apex distance nearly equal to 0 with an error tolerance of 5. And our loop, which has play ALS flail in it. And currently that results in this. You can see that the power IK ground is sometimes kicking in and sometimes it isn't. Which is interesting. Okay everyone, I'm back and I found the problem. So we can jump now. Power IK ground doesn't keep getting in our way. And I solved it by connecting our set jumping to false to a delay node set to 0.2. It's set into our that's plugged into our predict jump arc node. And the reason that works is because if we go into our animation blueprint, this is just some off-camera debugging. We can get rid of that. This transition from locomotion to jumping has a duration of 0.2. If jumping is set to false before this transition is done, it's going to exit out of it. And so I don't want that to happen. And so by setting the delay to 0.2, it finishes its transition. So now inside of jumping, we have this state with these 2 here. And we have our transition with our apex distance being nearly equal to 0 with a error tolerance of 5. And we've actually done everything in our jumping state. We're actually going to do our landing out in the very first layer of our animation graph, because I want to make extensive use of cached poses. The first thing I'm going to do is I'm going to rotate root bone out of this grounded state. I'm going to go back into my anim graph. I'm going to paste it right after this locomotion state. And I'm going to drag out from that and type in save. And it'll give me this option, save, new saved cached pose. I'm going to click it. And I'm going to name this Locomotion. And I had caps lock on. So I'm naming it Locomotion. Now I'm going to go into Locomotion, go into grounded, and I'm going to cut out local to component, leg IK component to local with Control X. I'm going to plug in grounded locomotion into output animation. And I'm going to paste this local to component, leg IK component to local twice. Move it down, give myself room. I'm going to type use saved or use save, or maybe use cached, and I'll get use cached pose locomotion. And I'm going to drag out from that, and I'm going to get a local to component. And from that, I'm going to get a transform modify bone. And I'm going to plug this straight into output pose so you can see what I'm going to do here. Translation is going to be -15. The bone is going to be pelvis. It's going to be in world space, and it's -15 on the z-axis. In translation mode is going to be add to existing. I compile, and it lowers our pelvis down a bit. I'm actually going to do -20. And while our feet aren't in the right place, that's because this leg IK isn't hooked up and doing anything. And we only want to lower the pelvis when we're jumping. And so this, or when we're landing. And so that's why we have these two leg IK nodes here. I'm going to get another new save cached pose. It's going to be called landing. And now I'm going to use cached pose landing on the bottom leg IK group of nodes, and I'm going to use cached pose locomotion on the top. And I'm now going to output. Actually, we're going to blend the output of both of these with a blend poses by bool. The true blend time is set to 0.1, false is going to be set to 0.2. And this is set to linear. I set that one state to linear because this was set to linear. But I think what I'm actually going to do is I'm going to set this blend poses by bool to Hermite cubic. And I'm going to go down into our jumping actually down into our grounded locomotion, and jumping to locomotion I'm setting back to Hermite cubic. That'll look better than linear. I'm going back into my anim graph. I'm plugging the result of the blend poses by bool into output pose. Now I can see our character is squatted down. And the active value, I'm going to use a new boolean called landing. And now I'm going to go into the event graph, Up here where I have this anim notify R foot down and L foot down, I'm going to get my land event or landing event. I'm not sure if that's what I called it though. So land. Yep. And that's the start transition event from jumping to locomotion. So event land. Here we go. Event anim notify land. What I'm going to do is I'm going to set landing to true. I'm going to get a delay. The delay is going to last 0.1 seconds. Then I'm going to set the landing to false. Looks like we're still permanently squatted down. Did I forget to plug landing in? Ah, no, I swapped these around. The top one, true, should be landing. False should be locomotion. Now, it will work. We can jump and we land. But we can't jump when we go sideways. You can move things around. There's lots of different ways to do it. I'm going to do it the easiest, quickest way possible to save on time. It is not the most efficient way. I'm just going to go into my locomotion state where I have all of my orientation warping, and I'm just going to grab all of my orientation warping stuff, everything except for my states. I'm going to copy and inside of this jumping state where we have our jumping state machine with start and loop inside of it, I'm just going to paste. I didn't copy everything. Dang it. Okay. I'm going to go back. I'm going to select all the orientation warping stuff. I'm going to copy it all. I'm going to paste that into the jumping state. I'm going to plug blend poses by int into result. I'm going to duplicate jumping with Control W. Plug it into orientation warping for forward and right. I'm going to duplicate it again. And I'm going to go into both of these and change the playback rate to -1 on both the animations. And duplicate it again. Both of these are going to be plugged into left and backwards. Compile, save, and play. Now we can jump while going in different directions, and you can get fancier with your sort of your bend down, your landing a distance. This is a bit much for this height of a jump. I think 15 is probably a better value, so I'll set it back. But you could like get the velocity of the character as they're going down, or the distance, or use that distance and say, okay, we're falling from 1,000 feet in the air, somehow we're just going to land and stand right up. That was an issue. We went past it. And it was like on the stairs, and we went past and we're never directly on it. So we could say the moment, the distance, to fix that, we could say that the moment, the distance between the actor and the location, instead of getting smaller, starts getting bigger. Just abort and blend out. And I think We can do that by, let's try doing it in our animation blueprint. I'm coming up with this stuff off the top of my head because I just saw the problem come up again. I thought it had been fixed, and that will definitely fix it. So jumping to locomotion, we have landing distance is nearly equal. Okay, I'm just gonna go into our character blueprint and do this. So after this landing distance calculation, I'm going to I need a landing distance last tick. So I'm going to duplicate landing distance last tick. So I have the set landing distance last tick and the set landing distance. So I'm going to set landing distance last tick before I set landing distance. I'm going to set it with landing distance. And so landing distance is 0. Landing distance last tick is 0. Landing distance is now updated to, let's say, just thinking this should work on the first frame. Should work. So before we update our landing distance, I want to check if landing distance last tick is greater than landing distance. Actually, if landing distance last tick is less than landing distance, or the easiest way to understand think about it, I think, is if landing distance is greater than landing distance last tick, that means we've gotten farther, which means we've passed it up. So if that is true, I'm going to promote this to a variable. I'm actually going to get a branch though. And so if that is true, I'm going to set this new variable, which is has landed, to true. And if it's false, I'm going to set has landed to false. Both of these are going to plug straight into set landing distance. And now I'm going to go back into the animation blueprint. Event graph. Set essential values. I'm going to get has landed. I'm going to promote it to a variable. Plug that in. I'm going to add an OR node onto here for this landing distance nearly equal to 0. So landing distance can be nearly equal to 0, or has landed can be true. The result is that we're going to transition back. Now, it doesn't break anything when we jump regularly. What happens when we jump down these stairs like before? It doesn't seem to work. Still. Why is that? Oh. Wrong variable. I got landing instead of has landed. I guess I just typed in landing or land and hit enter. So now it works jumping down the stairs. Our distance is getting bigger, it should be doing something. It's because we're only comparing z. So I'm going to, and I'm sorry everyone for all this being in the video. I'm just going to get the vector distance. Three-dimensional space, not one-dimensional. I'm going to set these values with it. Our values gotten bigger. So if our landing distance is greater than landing distance last tick, so we are setting landing distance with landing, we're setting landing distance last tick with landing distance. Let's say landing distance is 10. So we're setting that to 10. That's why. This shouldn't be plugged in between. This should be plugged in after. Compile, save, play. Gonna print a string here. That's weird. I'm not sure if that's the right thing getting printed there. Oh, I see. It's because we have this branch. So sequence. Then 1, do the branch. Then 2, check all of this. Will it finally work? I hope it does. Well, this is just terrible. Alright everyone, I'm going to cut the video here. 33 minutes of recorded stuff, and this works on a flat surface. But it doesn't work on a slanted surface. I'll try. So landing distance is greater than landing distance last tick. Should work. It's not. I don't know what to do, but I'll have it fixed for the next video, and I'll go over the fix in the beginning of the next video. I don't want you guys to just sit here watching me try for how long, not finding a fix. And so I'll probably cut out my extensive debugging and trying to different things out of this. And when the next video comes along, I will show you guys what I did to fix it. Because it works on flat ground, just not on ramps yet. I'm not sure why, and I didn't catch it before I sat down to record this. So I'll see you all in the next video, and in the beginning of that, I will go over the fix for the jumping sometimes on a ramp issue. Alright everyone, just a quick note. I missed something fairly obvious. If you just pull the isFollowing from the character movement component and set that as a variable inside of the animation blueprint, then you can use that plugged into a knot, plugged into the condition from transitioning from the jumping state back into the locomotion state, and that gets rid of all the issues when landing on slopes and stairs. And so that concludes the currently final video in the distance matching locomotion series. I hope all of you were able to learn something from the series. It was my first real series on the channel, where I tried to just cover a single topic and build something all the way through. I've learned a lot in the process of making this series. There's some things I did well, some things I could have done better with, and all in all, I think I'll be able to use what I've learned here to make my future series on the channel much better. And the reason I'm bringing it into an end here without doing anything on stride warping is because there's a bug or glitch of some sort inside of the custom anim node plugin that I only came across very recently. To summarize, the bug is that when you have a stride warping node plugged in and as part of your animation blueprint, when you try to change the character movement speed, the engine crashes. I haven't figured out a way around it, and I don't know enough C++ to try to attempt fixing it. And so until I can find another implementation that's free and something that you guys can all have access to, there's not much I can do. So I've just decided to bring this series to a close here and to focus on new and different content for the channel, since this series itself is already 99% of the way there, and everything that I've begun covering I've brought to, I think, a good enough conclusion. We have orientation warping, we have distance matched start and stop transitions, we have a basic turn in place implementation, and a slightly more than basic jumping implementation where the animation switches to apex, and I think that adds a good amount of realism there. I hope you guys all enjoyed the series, and if you did, be sure to like the video and subscribe to the channel because I have more content on the way, and I will see you all in the next video. Thank you for watching.